All right, number 45 on the Math 110 final exam review says, for the following rational function, find the coordinates of the x and y intercepts, the equation of the horizontal and vertical asymptotes, and then graph the function. All right, so same directions as number 44 that I just did in the previous part. So 45, we have y, or f of x, equals x minus 1 over x squared plus 2x minus 8. All right, first thing we want to do is factor that denominator if it does factor, which I believe it will. X and x, two numbers that multiply to give you a negative 8, that add to give you a positive 2. Going to have to be different signs, plus and minus. So actually we want their difference to be 2. So we're going to have the bigger number positive, the smaller number negative, and I believe 4 and 2 do the trick. So that tells us that this is undefined when x is negative 4 and x is positive 2, which then gives us our vertical asymptotes. This rational function has a larger degree function in the denominator, which means that it's going to get smaller and smaller as x gets larger and larger. So it approaches the line y equals 0, or the x-axis, as x gets large. So that's the horizontal asymptote. Okay. Up here in the previous problem, we were in the case where the degrees were the same. So this one had a horizontal asymptote equal to y equal 2. Y got closer and closer to just 2 over 1. But this one is what I call a bottom-heavy fraction, where the bottom outgrows the top. So it just gets to be a smaller and smaller fraction and approaches 0. So it approaches the x-axis. All right, so we've got vertical asymptotes, which are always x equal some number, and horizontal asymptote, which are always y equal some number. Okay, x-intercepts are where the whole thing is 0, where y is 0, but this fraction is going to be 0 if and only if the numerator is 0. So when you plug 0 in for y, you really only need to set the numerator equal to 0. So for the x-intercepts, in this case, x minus 1 equals 0 just gives you that x is 1. So that's the point 1, 0. And the y-intercept is when you plug in 0 for x. And so all the x terms go away if you're plugging in 0, and you just end up with the ratio of the constant terms. Negative 1 over negative 8 is positive 1/8. So that gives you the point 0, 1/8 for your y-intercept. So then you want to graph those. Plot those, I should say, and graph the function. So 1, 0 is right there on the x-axis. 0, 1/8 is just barely above 0 on the y-axis. Y equals 0, the x-axis is a horizontal asymptote, so you want to just kind of show that that's going to be a barrier, at least on the ends. And then the vertical asymptote, there's 2 of them at x equal negative 4 and x equal 2. So let's see, 1, 2, 3, 4. There's x equal negative 4. And 1, 2. There's x equal to 2. All right, and then from there, type it into your calculator. See what you can see on the graph there. So y equals x minus 1 over x squared plus 2x minus 8. Both in parentheses. Let's try a Zoom standard, zoom 6. And that looks pretty good. You have to realize it's following its asymptote. So there's its asymptote at -4, and here it has this asymptote at the x-axis. In the middle, it just kind of levels off and goes down towards its vertical asymptote, and then it has kind of an L-shaped piece that gets very close to that horizontal asymptote, and heads on. I wonder if a zoom decimal window, sometimes zoom decimal zooms in just enough. Zoom 4. Yeah, we just get a little piece of that part on the left, but at least you get a better view of the middle piece. So from those two, we can see how to draw this in. I'll extend my axis a little bit here. So it comes in the middle, close to that asymptote, going towards infinity, levels off, goes through that y-intercept and through that x-intercept, and then down towards that asymptote. And then on the ends, it's just got these kind of L-shaped pieces that you want to try to draw. Try to draw as best you can, approaching the asymptotes. Just L-shaped pieces, doesn't have to be perfect, but you want to show that it's approaching its asymptotes on both sides. All right, number 46. Solve the following rational inequality. All right, so now we have x minus 5 over x plus 2 is greater than or equal to 0. All right, here we want to do our find endpoints to the intervals. For an inequality, the solution is going to be intervals. When you have 0 on one side, it's extra easy. You basically just look at when is the numerator 0 and when is the denominator 0. Because the numerator is 0 when the whole thing is 0. So x equals 5 is when it's equal to 0. And the denominator equal to 0 tells you when it's undefined. So x equal -2 is when it's undefined. So both of those are going to be endpoints of the intervals of where it's true. So now when it's equal, we want to include that if it includes equals, which it does. If you have that equals bar in the inequality, then we want to include the endpoint where it's equals. Where it's undefined, we never include, because that doesn't make it true, that makes it undefined. So remember what that means is if you're drawing your number line and plotting these endpoints, 0, 1, 2, 3, 4, 5, 5 is going to be a included endpoint, so a solid dot, and -2 is going to be an unincluded endpoint or an open dot. And then you want to see which of these three intervals make this inequality true. And you can either just pick a number in each interval and test it to see if it's true or false, or you can have your calculator test it. So that's where you type in the inequality, parentheses x minus 5 over parentheses x plus 2. We want it to test, so we go second math to the test menu. When is that greater than or equal to? Option 4. When is that greater than or equal to 0? And a standard window is good to go. Looks like it's true to the left of -2 and to the right of +4. So you can double check that it switches from true to false at the endpoints that we found. That's important. You've got to find those endpoints algebraically, especially if they're fractions. You won't be able to see that on your calculator. But then your calculator tells you whether it's true or false. Remember, it gives a logical value of 1 if it's true and a logical value of 0 if it's false. So it kind of looks like you're graphing it on the number line. So then in interval notation, this is the interval from -infinity to -2, not including -2. union the interval from 5 to infinity, including 5, all the way up to infinity, and we always use parentheses around infinity. So there's your solution.